Okay, this is a redox recap, von Poe recap, so looking at voltaic cells and electrolytic cells and all the mnemonics that can help us decipher what's going on here. Also a little bit about section 24 and some general trends that they will expect you to know that connect with the activity series and table 24. Okay, so in terms of our mnemonics, we start with von Poe, which we should right away distinguish as von being about voltaic, oxidation negative, and positive oxidation in electrolysis. So we've got these two different categories. We've got the spontaneous reactions over here, and we've got the non-spontaneous reactions over here. And so in a voltaic cell, oxidation happens at the negative electrode. And so when we have the negative electrode, that is also going to be the anode. So von Poe tells us where the anode is. In electrolysis, the positive electrode is the anode. So the electrode is positive, it's also the anode, and this is where oxidation happens. Now in both of them, we can follow NOx red cat. The anode is where oxidation happens. And we can follow red cat, so the cathode is where reduction happens. Oxidation, reduction, oxidation, and cathode reduction. Okay, so now we've figured out our processes. We've got fat cat. Fat cat tells us that electrons always flow from the anode to the cathode. And that makes sense because at the anode, electrons are being lost in oxidation, and those are the electrons that are then free to flow from the anode through the external wire, through the external circuit conductor to the cathode. So that always holds true in both. So von Poe is a quick way of figuring out negative, positive, which thing is the anode. As soon as you figured that out, you know where the electrons are flowing from, and they always flow to the cathode. Now, one more that's a bit newer is metal cat. Think of a cat that loves heavy metal. So metal cat. At the cathode is where we should normally associate the formation of metal. And this really usually holds true in both. Obviously in HL there's going to be a bit more to consider, especially in electrolysis at the cathode, but metal is still always one of the options of what you will form. So at the cathode is where we generally form metal. In electrolysis, your general thinking about what is electrolysis, what is it used for? Electrolysis means splitting with electricity. So we're splitting something ionic apart, and ionic compounds are made of metals and nonmetals. So in electrolysis, remember metal cat, and by default, that means that the anode is where we will make nonmetal most of the time. And in SL, that's really all you need to remember. You only look at molten ionic compounds, and so you always make the metal at the cathode, and you make the nonmetal at the anode. You start with the ions. In HL, we add in a little more complication, but besides metal, we might also make hydrogen gas. And besides the nonmetal from our salt, we might also make oxygen at the anode. And we might also make a metal ion if we make the electrode out of something like copper or silver. In the voltaic cell, we usually make a metal at one electrode, and we usually make a metal ion at the other electrode as the other electrode falls apart, and in this one, it plates on. So those are some overall mnemonics. A good way to think about electrolysis being it's splitting ionic compounds, and we're making elements. So think about what kind of element am I going to make at each electrode. Metal cat, and therefore nonmetal at the anode. Metal cat also works in voltaic, to remember that we're going to usually form a metal at that cathode, and therefore the other metal is unforming at the anode. Okay, we've also got the use of table 24. Table 24 is basically the activity series. For HL, it also includes the electrode potentials. And in voltaic and in just any spontaneous reaction, so they might say at room temp, it's not electrolysis, this is activity series. The shape that we need to remember is the spontaneous Z. So in our activity series, we have the most reactive metals at the top, and we have the most reactive nonmetals at the bottom. And so the most reactive metals should react with the most reactive nonmetals spontaneously, negative delta G. And so we get this shape of a Z where we have our oxidation happening with our reducing agent, our metal. We have the electron transfer happening from up high on the right to down low on the left, and we get our reduction happening towards the right. And so with the spontaneous Z, actually the wider the Z, the taller the Z, the farther apart they are on this series, the more spontaneous that reaction is going to be. So think of the difference between these two half equations as being like your delta G. It's kind of a good visual for the delta G. The electrons are going down, just like delta G is negative. So I know it's a bit confusing that the electrode potential for HL is positive, but if you think of section 24, it almost just tells you about delta G. So if you were to look at a reaction, for example, like this, and they were quite close together, then you'd have a relatively small but still spontaneous reaction, small delta G. But if you took something from the very top of the table and reacted it with something from the very bottom of the table, and that was the electron transfer, then that would be a really spontaneous reaction. On the other hand, on this side, with electrolysis, we have to force electrons uphill. They don't do that on their own. And so on this side, we get the non-spontaneous C shape, where the electrons are going energetically uphill. And so we get our oxidation down low, our reduction up high, and this is where we are forcing the electrons with our power supply. And now in this one, this is a positive delta G, and so you should think about it as the bigger that is, the less likely it is to happen because it's less spontaneous. So with the C ones, we actually want skinnier C's are more likely than wider C's, because skinnier C's have smaller delta G positive, and wider C's have larger delta G positives. So when we think about section 24, think about the Z versus the C.